Okay, so let's warm up here. We've got arc cosine, also known as inverse cosine, of cosine of 19 pi 15ths. How are arc cosine and cosine related? They're inverses of each other. And inverse functions, when you compose them back to back in any order, typically, ordinarily undo each other, which means if that were the case here, we would simply be left with what we started with, 19 pi 15ths. But is that the case here? No, no, it's not. Because 19 pi 15ths is an angle, and I believe it lives outside our PVR, which stands for what? Principal value range, right? Okay. So yeah, we got to figure out. So let's go ahead and draw it. 19 pi 15ths is over here in quadrant 3, right? And we know that this is 15 pi 15ths right here at pi. We know this is 19 pi 15ths. So in quadrant 3, where we're living, is the cosine positive or negative? It's negative. Good. So what is the other quadrant where cosine is negative? 2. And that's the one that we need to be in, because remember, the PVR for cosine is the sun on the horizon, the stinky sun on the horizon, right? And so we need to be in quadrant 2. So the angle we want is going to be this one. It's going to have the same reference angle as the one we were given. So what is the reference angle? How far is it from 15 to 19? 4. Okay. So is 4 pi 19th the answer, or 4 pi 15th the answer? No, 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 no. Right. That's in quadrant 1. We need to back off 4 from 15 to get to what? 11 pi 15ths. Okay, good. So if this were a test question, this would be like A, this would be C, B, sorry, this would be C, D would be Daniel, I guess, D for Daniel, Daniel K, right? Yeah, Daniel K, which is Daniel Kilford, sorry, close, but yeah, sorry. And then E would be for peanuts, right? No, people could be allergic to peanuts. That's kind of, I don't want to do. How about E for electricians that don't wave? Electricians that don't wave. Yeah. Okay. Good. Wave back. Maybe they wave like when they're surfing or something, you know. Wave, surf, get it? Yeah. All right. So the answer would be C, as in Coco. Right? As in cosine. Very good. Someone said, when in doubt, always choose C, right? And that strategy works perfectly, brilliantly, 100% every time when the correct answer is C, right? Unless the answer is not C. So keep that in mind. All right. Any comments or questions on this? Yes. Big, medium smoke. Medium smoke. Extra medium smoke. We'll call it extra medium smoke. Extra medium is like a slightly larger medium.
There's a quote that like perfectly emphasizes that.
What is it?
60% of the time, it works every time.
Oh yeah, I've seen that meme where the two slides come together and they're 60% of the kids are making it off the slide. 40% of the time. Yeah. All right. Yeah. All right. I don't know. I do see a lot of memes because since I got off social media at the beginning of the year, which I did post something this morning, I might get back into it. But if you don't know, some of y'all know this app, right? 9gag. Y'all know about 9gag?
A little bit.
Yeah, a little bit. Yeah, it's a repository of memes, and they're separated by category. So I mean, if you want to like goof around, 9gag, I would recommend. There's some pretty good stuff. I basically have it set on. There's a funny category, which I like, and then there's a what the French fry category, and then there's also dark humor, which you know, you don't look at that at school, but you know, but then there's also satisfying, which is good, like when a box fits perfectly into a shell. Oh yeah. And then there's awesome, where like people are doing math and getting the right answer. There's also like wallpaper. So if you're looking for like new, there's all kinds of categories. Check it out. I'm not getting paid to advertise 9gag, but I find it I find it more satisfying than like strolling through Instagram, where you just kind of start getting jealous of other people's wonderful lives, right?
Network of social,
Yeah.
financial.
9gag is like you're laughing at. Right? Anyway. Uh-oh. It's not. Ooh, okay.
Or is it the chair?
So tomorrow I won't be here. Remember, tomorrow I won't be here. It says scam likely. I won't answer it. Tomorrow I won't be here. Coach Peck will be here. Remember Coach Peck, you're in good hands with him. You'll be working on your worksheet, and the worksheet is due, as I mentioned, Friday at 9 a.m. Okay. All right. So let's jump to example 13. We're kind of mixing it up now. Watch. Evaluate the following compositions. Sans calculator. Sine of, not arc sine, but sine of arc cosine. Wow, of negative root 2 over 2. Do these have a chance of undoing each other? Are those inverses of each other? No, they're not. So for these, you actually have to work them out from the inside out. So let's do that. What is arc cosine of negative square root of 2 over 2? That is, what is the angle in the PVR of arc cosine that has a cosine ratio of negative root 2 over 2? We should be in quadrant 2, right? And what's the reference angle where we get root 2 over 2? Pi fourths, right? So what's the pi fourths angle in quadrant 2? 3 pi fourths. Good. Okay. So that takes care of the inside part. If you want to color code it, this, well, that's too, really don't want to highlight with black, right? There, gray works well. So that becomes that. And now, what's sine of 3 pi fourths? What's the y value there? Positive square root of 2 over 2. Very good. Boom. See how fun this is? Yeah. All right. Letter B. Arc cosine of sine of 5 pi thirds. Are those inverses of each other? Are they going to do each other? No. So we just work it out from the inside out. Now we're starting with an angle. What is sine of 5 pi thirds? Sine of 5 pi thirds. Yeah, negative square root of 3 over 2. Very good. And now we bring the arc cosine down, and now we move on to the second part. What is the arc cosine of negative square root of 3 over 2? Well, again, we have to be in the PVR. It's negative, so it should be quadrant 2. What's the reference angle to get a cosine of square root of 3 over 2? Pi 6, right? That's where your x coordinate. And in quadrant 2, the pi 6 reference angle is 5 pi 6. Kaboom, right? Wait, was that him on the electric line exploding? No, he was successful. He did it. You know why he was able to succeed?
Because you were waving.
Because he was not waving back at me. He was focused on the job.
You were waving at him.
Okay, that's right. That's right. All right, inverse tangent of cosine of pi. What is cosine of pi? Nope. Nope. -1. Kaboom. There you go.
That's right.
Boom. Kaboom. And now, what's inverse tangent of -1? Ooh, what's the PVR for inverse tangent? Half moon. But remember, you're not allowed to use pi halves at negative pi halves. Okay. But because it's a negative ratio, it should be in quadrant 4. And what's the reference angle where tangent is 1 or -1? Pi fourths. Okay. So what is the pi fourths angle in quadrant 4 that we want? 7 pi fourths would be an answer choice on the test.
-1 pi fourths.
Negative pi fourths is the correct answer, right? We don't get to quadrant 4 by going all the way around. Drake doesn't like it. We get there by going straight down, right? Straight down. Okay, good. Fun. All right, you do this one on your mark, get set, go. All right, let's see how you did. I'm going to bring the cotangent down right away. We're going to focus on this. Arc sine of negative square root of 3 over 2. What's the PVR of arc sine? Half moon. with pi halves and 3 pi halves included, or pi halves and negative pi halves included. And because it's a negative ratio, it should be in quadrant pure. What is the reference angle that has the sine, the y value, as the square root of 3 halves? Pi thirds or pi sixths? Pi thirds, good. So what is the angle now that we want in quadrant 4? Negative pi thirds, good, boom. And now what is cotangent of negative pi thirds? Well, cotangent of negative pi thirds is actually equal to cotangent of 5 pi thirds. That's a legal statement, isn't it? Can we say then that negative pi thirds equals 5 pi thirds? No, the angles don't equal each other, but because they are coterminal with each other, they do have the same trig value there, right? Coterminal angles have the same trig value. So I invented a symbol for coterminal several years ago. I haven't really showed y'all, or maybe I did once, but you know how theta is what we use for angles? If you put two lines through it, it kind of looks like an equal sign, but it also still resembles theta. I would like this to catch on nationwide to be the symbol for coterminal with. So if you can help me with that, that'd be great. I'll give you all the proceeds. We'll split it evenly, okay, that I get from that. But there needs to be a symbol for coterminal, and there's not. So I would put this one. Do you think it's pretty good? Right, you can't put cot, right? Like you're going on a camping trip, you're going to sleep on a cot. What are you bringing cotangent with you on the trip? People are going to get confused. Yeah. So let's go ahead and write the ordered pair there at 5 pi thirds. Yeah, your phone. It is 1/2 comma negative square root of 3 halves. Cotangent is x over y. Forget about the 2's. It's 1 over negative root 3, which when we rationalize is, yeah, negative square root of 3 over 3. Boom, good, got it. Fun. Almost as fun as riding around in a bucket truck. Yeah, almost. When you're in the bucket. If you're driving, it's not as fun when you're in the bucket. Unless you're raised up and you're traveling down the highway at 80 miles an hour heading towards an overpass. That might not be as fun. So, you know, situational funness.
Yeah.
What about the lights?
Which lights? The northern lights? The aurora borealis?
No, the lights on
The sun is a light.
Letter E, tangent of sine of 2 pi. Now take a look at this fella. We have so far been doing trig of inverse trig or inverse trig of trig. This is trig of trig, isn't it? Wow. So interestingly, watch. 2 pi in this case is a what? Angle or a ratio? It's an angle because it follows sine, right? So we take sines of angles to find ratios. So what is the ratio of sine of 2 pi? 0, right? That is the ratio that is sine of 2 pi. But now watch, as soon as I bring the tangent down, now, since it follows tangent, it turns into an angle, which is perfectly fine as long as, if I expect you to evaluate it, as long as it's an angle on the unit circle. There are very few angles that are the same as ratios, right? 0 is one of them. So what now is tangent of the angle 0? 0, right? A very anticlimactic problem, right? It's just 0 all the way, right? You thought it was exciting and fun, but it's just 0. Which is how many electricians we've lost so far outside in the bucket trucks on the wires.
It's also the amount of
The amount of what?
electricians that have waved back.
Oh, that's also the amount of electricians that have waved back to me. It's true. That's better. It's better because they were paying attention. All right, you do this one. Letter F, go. Bless you. I was just thinking if Andy Serkis had 3 wives, what religion is that? Mormon? Oh, I don't know. Lil Wine, can you get married more than once? No. Polygamy? Is that no longer, is that a Mormon custom? It used to be. Way back. There's some people that still try to pull it off, right? Yeah, like Sister Wives. There's a show called Sister Wives, but it's illegal, right? And it's not part of the faith anymore. Right. But anyway, thank you. Yeah, thank you. I figured you'd know. Right. Not you would know when the anniversary of the, but you know that, right? But anyway, if Andy Serkis, let's say he had 3 wives, he would be a 3-ring circus. Yeah. You're welcome. All right, let's work this one here. Secant of tangent of pi. What is tangent of pi? 0. That's the ratio that is the tangent of pi. Now 0, the ratio, changes hats and becomes 0 the angle once again. What is secant of the angle 0? 1, right? Because it's the reciprocal of cosine of 0, and cosine of 0 is 1. So boom, it's 1. Yeah. Fun. Yeah. All right. We're going to keep going. Inverse cosine of arcsine. So now instead of having trig of an angle, we have inverse trig of a ratio. Let's see how this works. Bring down the inverse cosine. What is arcsine of 0? The PVR for arcsine is this. So sine of what angle is 0? Sine of what angle is 0? 0, right? Sine of 0 is 0. Yeah, good. And now 0, the angle, changes hats and becomes 0 the ratio. What is the inverse cosine of 0? Cosine of 0 is 1. Cosine of 0 is 1. But the inverse cosine of 0, now we're looking in the PVR, where is cosine 0? Cosine of what angle is 0? Yeah! Way to go, extra medium smoke. I have. You don't like that moniker? Brady, what would you like to be called? You deserve to. Your name? Okay, your name it is. Your name, thank you for telling us it's pi halves because, yeah, cosine of pi halves is 0. Thanks, your name. How do you spell your name? Your name? Your name. Your name. Is it your name or your name? Your name. Accent. No, your name. Your name. Good. So good. N-E-I-M. Oh, N-E-I-G-H-M. Oh. Yeah. Okay. Got it. Interesting name. Is that Polish? All right. Sine of, look at this. Sine of twice arc cosine of a half. So now we're back to trig of inverse trig. We got a 2 right here. Hey, when in doubt, don't panic, right? Just work it out from the inside out. You know what I'm saying? Let's do that first. Let's do that first. What is arc cosine of a half? Where is cosine equal to a half? Yes, pi turds. Now, what do I do with the 2 that's there? Well, it's 2 times arc cosine of a half. So now it's 2 times pi thirds, which is the same as what? 2 pi thirds. Hey, and now what's sine of 2 pi thirds? Square root of 3 over 2. Kaboom, right? Kaboom. Thank you, Brady. You're on fire today. Unlike the electricians outside. Electrical fires can happen if you're not safe, right? I never, ever, ever had the idea growing up of putting forks and knives and utensils into electrical outlets until my parents told me not to do it. And I'm like, well, that's crazy. Yeah. So, the sheer mentioning of something gives you the idea to do it, right? When it necessarily wouldn't even enter your mind otherwise, right? Right. Yeah. So anyway, it's crazy. It's crazy. It's crazy I survived with all the warnings my parents gave me growing up. Somebody must have one time said, hey, don't marry more than one woman at a time. And so I never even thought about that, right? And then how many wives did Joseph Smith have?
At least 34.
He had a few, right?
At least 30.
Has anyone seen that show, Sister Wives? No, it's like on like the Learning Channel or Bravo or something. And it's a guy and he has like 5 wives and they're all like friends with each other, And one of them is in charge of like the floors and the other one's in charge of like the walls, They have like, yeah, I don't know. It's kind of like modern day slavery, So anyway.
Anyways.
Yeah. Do you know that if you're going to apply for a wedding license, you don't have to give proof that you've been divorced if you've been previously married. You just have to sign an affidavit saying that you are eligible for marriage because you've been divorced. But they don't check.
No way.
No, they don't. All right. I think that law needs to be changed, right? Yeah. Monogamy, faithful monogamy. Secant of arctangent of sine of 3 pi halves. Whoa, we got 3 of them now, right? Kaboom, kaboom, kaboom. Is it time to panic? No, it's time just to be chill and work it out from the inside out. So here we go. Let's bring down the stuff we're not using. And we'll just kind of go one little piece at a time. What's sine of 3 pi halves? -1. Yes, nice. The next layer then, let's bring down the secant. What is arctangent of -1? I'm not even drawing the PVR at this time. -pi4. Very, very good. Very good, Colin. And now what's secant of -pi4? We're down here, right? Which the ordered pair is square root of 2 halves, negative square root of 2 halves. Secant is the reciprocal of cosine. Square root of 2. Yeah, buddies. That's good. That's good. So you can see that these are called, yeah, thank you. These are called compositions, right? Secant of arctangent of sine of 3 pi halves. It's not multiplication. And I could string along 4, 5, 6, 7 of them if I wanted, right? It's just a sequence. You work from the inside out, like you're trapped inside of an onion and you're trying to get out of that dang onion.
So many layers.
They do.
Just like ogres.
They do. Okay. Ogres. Very complex individuals.
No matter what we do, we can never escape Shrek.
Oh, you're right. Shrek was good. All right. Let's look at the last little piece here. If we replace the numbers that we've been using with the variable x, we can still do the procedure, but we're going to have to do it in a slightly different fashion. What we're going to do on example 14 is we're going to take these trigonometric expressions and we're going to write them as equivalent algebraic expressions. And that's going to be known as an identity. An identity is basically an equation that gives you mathematical synonyms. Kind of, yeah. Like the absolute value of x is the exact same thing as the square root of x squared. That's called an identity. We use that quite a bit in calculus. All right. So let's go ahead and start with this. Cosine of arctangent of x. Here's how we do it. Start with the x. Ask yourself, is that a variable or is it a ratio? I'm sorry. It's both. It's a variable. Is it an angle or is it a ratio? It's a ratio. We know it's a ratio because it follows an arc or an inverse. Now, it doesn't look very ratio-esque, does it? So let's put it over 1 now to make it more ratio-esque. When we take the arctangent of that, we're going to get an angle theta. I don't know what the theta is because I don't know what x is. But what I'm really after is not theta, right? What I'm really after is the cosine of theta. And so I'm going to be left with a final answer that is also a ratio. And not just any ratio, it's going to be the cosine ratio. So I'm starting with the ratio x over 1, and I'm ending with the ratio. Well, how are we going to do this? Remember, when you're given a ratio, you're really given 2 of 3 sides of a right triangle. Yes, yes? And if you have 2 of the 3 sides of a right triangle, can't you find the third side? Yes, by the what theorem? Pythagorean theorem. The P theorem. You gotta go. And if you know all 3 sides of the right triangle, do you not have all 6 trig functions at your disposal?
Yes.
Yes. So that's our strategy. We're going to find the third side in terms of x, and then we're going to pluck the cosine ratio off that triangle. So off to the side here, let's draw a right triangle. I don't know what quadrant we're going to live in for theta, so I'm just going to always use the first quadrant just for reference, okay? Now I'm going to drop a perp, right? Drop a perp. Let's go ahead and label the 2 sides. X is the tangent ratio. Yes, yes? Yes. The tangent ratio is y to x. Y to x, which is vertical to horizontal. Now, this is going to look a little strange here, but I'm going to label the vertical as x and the horizontal as 1. See that? Because y over x is a different context than x over 1. Yes?
Yes.
So you can also do TOA if you want. Opposite over adjacent, x over 1. And now that I have those 2 sides, it's time for the P theorem. Let's call the hypotenuse r like we typically do. So 1 squared plus x squared equals r squared. Yes, yes? How do I solve for r? Take the square root. Yeah. And we're always going to take the positive root here because r is always positive. And even if it were x, we would assume quadrant 1 because it's in the PVR. So this is 1 plus x squared. So now I have the hypotenuse in terms of x. And now that I have all 3 sides, I don't want theta. I want the cosine ratio. Well, what's the cosine ratio now? It's adjacent over hypotenuse, or x over r.
So it's x over square root of
X or adjacent, which would be 1.
So it'd be 1 over square root of x plus 1?
Close, right? 1 over the square root of 1 plus x squared, or x squared plus 1. Yeah.
But those are the same thing. Square root of x squared plus 1.
Is the same as 1 plus x squared under the root. Yeah. Correct. Yes. Yes. And that's your answer. That's your answer. So here's what we have. We have cosine of arctangent of x. It's the exact same thing as the square root of 1 plus x squared. These are identities. They're mathematical synonyms, right? If you're writing a paper, and in the paper you're writing, the boy looked at cosine of arctangent of x with amorous affection. You could change that to, the boy looked upon 1 over the square root of 1 plus x squared with amorous affection, with no loss of generality. The reader's going to be like, Oh, he must have got that out of a math thesaurus. That's the same thing. Okay. Why would it be so useful to have two different versions of the same thing? Depends how you're using it, right? In calculus, we might prefer working with the right side because it's purely algebraic, or we might prefer working with the left side because it's purely trigonometric. It depends what we're going to be doing with it. And they look dramatically different. So it is nice to have options. This is an identity. It's true for all values of x in the domain of the function. The left side will always give you the same value as the right side. It's not something that we're trying to solve. They're synonyms of each other. What do we call that when we have an equation and the two sides are equal for all values? We call it a what? An identity, right? Like when you look in the mirror and you see yourself, you're like, hey, that's me. That guy he could substitute in for me. Hey, I'm not going to school today. You're going to school today. That's right, buddy. You're going. You're my substitute today. When I was young, my coach always made us run laps. He was a mean guy. And I hated running back then just because he told me to. I really enjoyed learning later in life. But I always thought, I'm going to build a robot that I can crawl inside of, and I'll control the robot and I'll make the robot run, and that'll be better than me running, And I'm like, I wonder if he'll notice. But in my mind, to me, it was always better that I would be probably doing more work controlling the robot, trying to make it run. Or maybe I control the robot's legs with my own legs, right? And so I'm actually running. But to me, it was the robot running. And so like I was off the hook. I didn't have to do it. Yeah. That's from the same genius mind that thought that dogs were boys and cats were girls, and they mated. And if they had a boy, a dog came out. And if they had a girl, a cat came out. Yep, that was me. Yep. And I've learned a lot since then. And I now know that cats are the boys and the dogs are the girls. I figured that out. Yeah. All right. All right. Biology class. There we go. All right. Sine of inverse cosine of dos equis, 2x, right? Is 2x an angle or a ratio? It's a ratio, okay? It's the cosine ratio. Let's put it over 1. Now, this is going to give us some angle theta, but we don't want theta, do we? We want the sine ratio of that theta. So let's go off to the side and draw ourselves a little triangle. There's the theta, drop a perp. Label the two sides. Cosine is x over r, or adjacent over hypotenuse. So I'm going to label the adjacent side 2x, and I'm going to label the hypotenuse 1. Now I need to find the missing side. Let's call it y, okay? Y. So now by the Pythagorean theorem, careful here. It's y squared plus, is it 2x squared like that, equals 1? No, the 2x is in parentheses. We know better than that. Y squared plus 2x squared equals 1. I want to solve for y. Now notice on this one, they were both positive terms because they were both the short sides, right? Short side squared plus short side squared, square root is the hypotenuse. But now, because we have the hypotenuse, to solve for y, I'm going to have to subtract, yes? So now y squared is the square root of 1 minus 4x squared. And this is the hypotenuse squared, yes? I know it's the hypotenuse squared because it's hypotenuse minus the short side. Is 4x squared the hypotenuse squared? No, because it's the negative term. The positive term, when you have the 2 like that, is the hypotenuse. Oh, and I already called that y squared. Silly me, that's just y. Well, it's 2x quantity squared, right? So 2x times 2x is 4x squared. Yeah. That is a mistake. That's an error alert, right? Error alert. A lot of students make that mistake. All right. And now that I know the y value is the square root of 1 minus 4x squared, I know all three sides. Let's go ahead and pull the sine ratio off. What's the sine ratio of this triangle? y over r, or opposite over hypotenuse. So it should be the square root of 1 minus 4x squared over 1, also known as the square root of 1 minus 4x squared. And there you go. That's where we'll stop today. You have your own identity right there. Did we finish the notes? No. You know what I might have Mr. Peck do? I might actually have him finish the notes.
How's he gonna do that until it's
No, you know what I might do during my conference period today? I'm going to record a video of me finishing the notes, and you can watch it tomorrow in class with your earbuds before you finish working on your worksheet. Okay. So bring your earbuds tomorrow. I don't want to have Mr. Peck play it live for everybody, or you can watch it tonight. It'll be in the shared folder, but I'll go through example C and then 15. 15 is good because we're going in reverse. We're starting with an algebraic expression and we're going to write the trig expression. All right. All right. So if you have questions tomorrow, Mr. Peck will be able to help you. And he knocks harder than I do. So if there's electricians again, he could probably get their attention. All right. Y'all have a super duper awesome rest of your day.